Welcome to the 7th video in this video series of using Godot with C# and the Writer IDE to dynamically modify a 3D mesh. In our last video, we used our knowledge that we learned about immediate mode geometry to create a set of axes for display on the screen. In this video, we're going to take that knowledge and we're going to create surface normals coming off of the faces of the cube that will later help us in modifying the 3D mesh. The first thing we're going to need to do here is to try to refactor some code. We have everything kind of bunched together in that ready method, and it's already difficult to work in, and it's going to make it even worse when we implement this. So we're going to move some code around, and luckily Writer has a nice way to help us refactor this code. So let's go to the Writer IDE, and so inside this ready method, I mean, we're doing pretty much everything in here in this one method. We're creating the wireframe, and then we're pointing the camera at the cube, and then we are drawing the axes. And let's break this up a little bit so that we don't have everything all clumped together at once. So let's move some of these things to different methods. So the part here that's actually going to be the code that actually generates the wireframe, let's move that to its own method. So what we do is we highlight the code we want to move in Writer, and then we right click, and then we go to refactor, and then we do refactor this, and then we want to extract the method. And it asks what the name of the new method is going to be called. And I'm going to call it draw wireframe. And then what you'll notice when it's done here is, you'll notice in the ready method here, we now have a call to just this draw wireframe. And it created a method called draw wireframe, which all that text that we had highlighted, it put into its own method. So the next thing we want to do is we want to move the axes code to its own method like that as well. So let's highlight everything that does that. Right click, then we will refactor this, extract method, and this one will be called draw axes. And we'll hit next. And you'll notice it has a new function here called draw axes. And in the ready method here, we have a function called draw axes. And this isn't, we probably don't need to do this one as well, but let's move the camera pointer code to its own method as well. So refactor this, extract method, and then we want to, let's just call it point camera. Okay, so in our ready method now, it's nice, it's a lot cleaner. So we just have the draw wireframe, point camera, and draw axes. So fantastic. So what I'm looking to do here now, we'll go back to Godot. So when our game is running, it would be nice to see where the surface normals are. So like off this triangle, it'd be nice to have a line coming off here that's obviously perpendicular to the face, so that we would have a better visual representation of where the surface normals are. This will be handy later in a future video when we're actually selecting face surfaces, and we actually have to compute the angle of the surface normal compared to the vector that's coming from the camera to the cube. So it'd be nice if we could visually see that, so it's better. It would be easier for us to understand how that's going on. So why not do it now? So let's go back to Writer, and because we just took those methods and refactor that code out to methods, let's kind of do the opposite here, and let's create the method from the get-go. And this one will be called draw face normals. Okay, and then what we want, let's go ahead and steal what we're doing for the wireframe, and then we're going to make changes, but a lot of it's going to be the same. So let's just copy paste, and then we can go from there. So let's copy paste it in that method. Okay, now in order to get the surface normals of the face, we could compute that ourselves, but we haven't really covered cross products yet, so I really don't want to do that. However, if you remember from the very first video of this series, our friend the Mesh Data tool has all sorts of convenience methods. And one of the methods that it has is to get the face normal for a given face. So let's go ahead and just use that. That way we don't have to do any sort of math ourselves. So let's go ahead after we get the vertices out of the mesh, and let's create a new Mesh Data tool. And if you remember from the first video, the way this whole thing gets started is you send in a mesh for the create from surface, and we're going to send in the cube mesh, and the surface is going to be 0. So now we, and if you remember from the first video, we had to cast it to an array mesh. Not a mesh, a mesh. Okay. So going down here, we're looking at the all the things we're doing with the material that we did in the last video. We probably want these normals to be a different color. Let's make them white. And we're not going to go through the loop and iterate through the vertices. We're going to iterate through the faces. So we would use the Mesh Data tool, and we would go to the face count, and instead of doing a stride of 3, we're just going to do our standard I++ because there's no reason to skip like we were doing. And so what we want to do here is we probably want to keep track of, we're going to need to get, much like when we were doing with the wireframe here, we're going to need to get the 3 vertices of a given face. And the reason for that is because what we would like to have happen is we would like the surface normal to be in the center of the little triangle here. So you see the triangle here. We would like it to start right here in the center and then draw out like that. So we would need to get the average of these 3 points so we know where to start drawing the vector. Otherwise it'll draw from 0, 0, and it would be an interesting shape that we would have there, and it wouldn't really help us any. So what we want to do here is we'll start getting those 3 vertices, but then we'll do something so that we can offset on what face we're on. So what we're going to do here is we're going to, remember a triangle is made of 3 vertices. A, B, and C is what we had been calling them before, so let's just call them that now. And we'll grab out of the vertices array. We're going to put I here for now. I is not correct, but let's just, because I, in our previous wireframe method, this the for loop for that was iterating through the vertices. Well, this isn't iterating through the vertices. This is iterating through the faces. So the I isn't what we can use here, but let's just put it in here to get code on here, and then we'll work from there. So A, B, and C. Now we remember from the wireframe that B was +1 and C was +2. So it's like, well, okay, we can't use I. What can we use? Well, remembering each face has 3 points. So what if we make a variable here called, let's just call it face index. And what if we say it's I times 3? So the first time through the loop, the face is going to be 0. So 0 times 3 is going to be 0. Well, so instead of in the wireframe when you're doing I plus 1, I plus 2, well, since we're iterating, let me make sure I explain that, because so here's the wireframe one, and see with the wireframe loop, we were iterating through all the vertices. So we could just use I directly, I plus 1, I plus 2. But we can't do that in the loop we're doing now because we're iterating through the faces. We're looping through the faces. We're not looping through all the vertices. But we need to get the vertices for a given face, and that's why we're going to have to do this little bit of magic here. So instead of I, what we're going to use is face index. So this math is the same, except instead of I plus as the starting point, we're going to do face index plus. So then, like, the second time through this loop, this I will be 1. Face index 1 times 3 is 3. So then this will start at the next 3 vertices. And do you see how that works? It's going to go ahead and keep scooting along the vertices. Okay, so now we want to compute the center of the triangle, the face. So what we want to do here is we want to create another vector, and we'll call it center of face, and it's just going to be the average of those 3 points. So A plus B plus C, and we're going to divide by 3. And let's give a capital O for center of face. Okay, so that's going to put us at the center there. So we want to draw the surface normal. We don't need all this. Basically, this is going to draw, since we're in line drawing mode of the immediate geometry, we need to get a starting place and an ending place for the line. Well, it's not going to be vertices I and vertices I plus 1. What it's going to be is the starting point is going to be the center of the face. And the ending point, well, it's tempted to just do this. Query the mesh data tool and say, give me the face normal, and you'll see the tooltip here. It says calculates and returns the face normal of the given face, and it's an index. And this for loop is going through the faces. Each face is 3 points, but we can use this method to get back the normal without computing it ourselves. So it's tempted to just do this and put an I in there and think it's done, but that's not going to work. And let's go ahead and set this so it runs. So the immediate end, we're not going to do any scaling, and we'll just add it to the child. So we're not going to do, this isn't going to work exactly, but I'll explain why that last thing isn't correct. So after draw axes, we want to draw face normals. Actually let's do face normals right after wireframe. It doesn't matter, but just logically to me that makes sense. All right, so let's go back to Godot and run this, and the face normals aren't quite going to be right, but they're going to be close. And what we'll notice is, well, we have something that doesn't really look like we would want. And the reason for that is the surface normal itself is like in this direction, since this is the z direction, it's going to be 0, 0, 1. And since we're starting it there, we need to somehow offset the end of the surface normal so that it can draw from the center of the triangle to where it needs to go. And that's actually really easy. So what we need to do is we just need to add the center of the face to this normal vector. Oops. And that'll fix it, because we're going to then offset the face normal, which is going to be 0, 0, 1, and we're going to scoot it up to where the center of the face is. So then from that point on, it's going to move in the direction it wants. So let's go ahead and go into Godot and run that. And we should notice that our normals look better now, and they do. So you notice for each triangle, we have a white line coming out that's perpendicular to the face. And that's what we want here, because as I said, later on in the series, we're going to be selecting faces, and we really are going to be doing some math here. And this surface normal, the angle between the vector from the camera to whatever's selected, and that vector coming off the face norm, that's going to depend whether a face is facing away from us or toward us. So I thought this would be a nice continuation to use the immediate geometry. But then, you look here, and we've got a lot going on here with these surface normals and these axes and the wireframe, and it'd be nice if we could conditionally toggle those off. And if I don't know how many people are familiar with this, but in Godot you can set up a class variable, and if you give it the export attribute, when you click on the scripts node, in here you'll see you'll see those variables, and you can set those to different things. So let's go ahead and do that so that we can toggle stuff on and off. So let's go back to Writer, and let's go to the very top of the class here, and let's make a few variables here. So let's make a private boolean, and let's call this show wireframe, and we'll initially set it to true. And then let's make another one, and we'll call it show axes, and we'll set that to true. And let's make one more, and we'll call this show face normals, and we'll set that to true. Now, by itself, we're not going to see anything. Here's where it gets interesting. Well, interesting in that, well, there's different steps here to know how to get this to work. So again, we're on the main node. You would expect to see this here. I don't see anything. You hit the play button, and we're still not going to see anything. The reason I'm mentioning hit the play button is because when we get this in the final state, you're going to have to hit the play button once to see those variables. The Godot needs to build C#, the project, before it can actually expose those variables. But they're not being exposed in either setup now. Well, that's because we didn't give it the export attribute. So what you would do is over each variable you want to export to the editor, you would just put this in front of it. So now these three variables, this export says that the variable that's after it, that's declared after it, export it out to the editor so we can do something with it. So if you go back to Godot, and you'll notice it's still not appearing there. And the reason I mention that is because I believe when you're using GD script, like on the fly, as soon as you enter the code there for the export variable, like as soon as you go back to the editor, they'll immediately appear here, and that's not the case with C#. It has to build once. So we have the main node selected, and I don't see those variables here, so I'm going to hit the play button. And I don't know if you've noticed, I'll close this up, but now you do see these. It's the script variables, and there's checkboxes for the three things that we set up. Now, they don't do anything other than show in the editor because we didn't add any code to do anything with those variables. So if we go back to Writer, we can certainly do something with these, and that's why breaking those things out into different methods are going to make this really simple. So if we just wrap this draw wireframe inside an if for show wireframe, that takes care of that. If we do a show face normals, and we wrap that, and then we do a show axes, and we do that. So based on those variables, it'll determine if it's going to draw the wireframe, draw the face normals, or draw the axes. So let's go back to Godot. These are all set to true initially. Let's just hit the play button. Hopefully nothing's different. It should all look the same. And it does. Everything's displayed, the axes, the face normals, and the wireframe. But now we can start toggling these. So like, let's not show the wireframe and hit the play button. And the wireframe shouldn't be showing here. And it's not. Now this is only useful when you start the game up. It'd be nice interactively if we could toggle these, and we could set up GUI elements on the screen and do that, but I think that's going to distract from what I'm trying to do here, so I'm not going to do that, but I did want a way where we could toggle these off. So obviously if I shut all of these things off and hit the play button, we should get just a very plain looking cube with no wireframe, no normals, no axes, no anything. So that's exactly what we wanted, so that we can start turning this stuff off, so like we only have to turn it on when we want to see something interesting. Okay, Well, I think that'll do it for this video. The next video, I think what I'm going to do is we talked about at the very beginning of this series, we talked that there's two ways in Godot to dynamically create something on the screen. The immediate mode geometry, that's what we've been using, or immediate geometry, excuse me, that's what we've been using to draw the axes and the wireframe and the surface normals. But if you remember way at the very beginning when I was saying, well, we've got to pick one of two ways, there's two ways to do this for the wireframe, and immediate geometry seemed like the easiest way to do it, and it was. But if you remember that we talked about the surface tool, and the surface tool is how you would create a mesh on the fly. And I think what I want to do for the next video is this green cube that we brought in this mesh instance. So if you remember, we exported out the cube out of Blender, and then after we got the cube added to the mesh instance that was exported from Blender, which we called mycube.obj, then we went to this mesh menu and we created a static body for it. And then on the static body, we went ahead and we added some signals to some events there. And what we're going to need to do, if we're going to dynamically create the mesh ourselves, we're going to have to encode, generate the static body with the collision shape, and then we're going to have to encode, attach those signals. And that's actually not as hard as it sounds. I was surprised at how easy it is, but I guess that's why Godot does the things it does. So that's going to be the topic for the next video. I hope you enjoyed this video, and I will talk with you soon. Take care.